Hello everyone, welcome to Toppscholars, the smart learning app. Today in this lecture, we are going to discuss some of the previously asked questions from the last 5 years of the Maharashtra State Board. And today we are going to discuss refraction of light. So, before we get into those questions, first let's have a look at the statistical data over here. This data over here shows us how many questions were asked in each year since 2019. As we can see, 2019, 20, 21, 22, 23. These 5 years, we have had multiple questions that were asked. Like for example, for 1 mark, for 2 mark, 3 mark, as well as for 5 marks, some questions have been asked. So we can see here in the year 2019, we have got 1 mark question, that is just a 1 question, and we have got one more 5 mark question. Then here 2020, 1 question for 1 mark and 1 question for 2 marks. Then in the year 2021, we have got 1 question for 2 marks and again we have got 1 question for 5 marks. And if we come to this year 2022, we have got 2 questions for 1 mark, 1 question for 2 marks and we have got 1 question for 3 marks. Similarly, if you go to this last year 2023, we have got 3 questions for 1 mark and we have over here 1 question for 3 mark. And in this way, we have got 7 1 mark questions, 3 we have got 2 mark questions and we have got 2 3 mark questions and 2 questions for 5 marks. And in total, if you look at this, then 7 marks for 1 mark questions, 6 marks for 2 mark questions and 6 marks here also for 3 mark questions and 10 marks for 5 mark question. So in total, if you look at here, then we have got 7 plus 6, that is 13, 13 plus 6, that is 19 and 19 plus 10, we have got 29 marks. So far in the last 5 years, we have got 29 marks of questions from this chapter. And you can see also over here, year wise also we can calculate. This is 1 plus this is 5 marks. So this is 6 marks. Then here 1 plus 2, that is 3 marks. And here 2 plus 5, that is 7 marks. And here 2 plus 2, 4, 4 plus 3, 7 marks. And then here we can see 3 plus 3, that is 6 marks. So on an average, we can see here this question carries almost 6 marks every year. At least 6 marks per year we can see the questions are asked. So that means this question or this chapter is quite important from the board examination point of view. Okay, so that's why today we are going to discuss some of the questions from the last 5 years of board examination from the Maharashtra State Board. So what we are going to do is, we are going to have a look at all the questions that were asked in the last 5 years. Then at the end of this lecture or at the end of this video, we will have a look at the solutions for some of the questions asked in these last 5 years. Okay, so let's start our lecture and let's see which are those questions. So here it is. This is the first question from the year 2019. So the first question is, a ray of light makes an angle 50 degree with the surface S1 of the glass slab. Its angle of incidence will be what? So it is very simple. So as we know, we have got a glass slab and here it is. Let's say this is the incident ray and we can see this is the normal, let's say incident ray is, let's say, AB. And here it is given that the ray of light is making an angle 50 degree with the surface, right? So now we have to calculate what is the angle of incidence. So here it is, right? So this total angle between the surface and the normal is always 90 degrees. So 90 minus 50, it is 40 degree. So our answer here should be 40 degrees, right? So this is a very simple question. This is a MCQ for 1 mark, right? So this is a simple question. Moving on to the next question, again from the year 2019. So let's have a look at this question. We are going to discuss this question later on in details. Okay, but let's have a look at this over here. The observation made by Swarali while doing the experiment are given below. Based on these, write answer to the questions. So first of all, this is the observation that she has got. So Swarali found that the light ray traveling from the denser medium to the rarer medium, so it is traveling from denser to rarer, goes away from the normal. If the angle of incidence I is raised by Swarali, the angle of refraction went on increasing. However, after certain value of the angle of incidence, the light ray is seen to return back into the denser medium. Okay, so these are some of the observations that Swarali has got from her experiment. Now, what are the questions? What is the specific value of angle I called? Then second question is, what is the process of reflection of incident ray into the denser medium called? Okay, and the third question is, draw the diagrams of the three observations made by Swarali. So these are the questions. So let's not discuss this right now. We will discuss this later on. Okay, in details. This is a large question, as we can see, for 5 marks. So definitely we are going to discuss this at the end. Okay, moving on to the next question. This is from the year 2020. So it's a very simple question. You can see it's a very short answer question just for 1 mark. So here we have to match the columns. So in the column A, we have got the wavelength of red light. Okay, so here we have got 3 options. As we know, the red color, as we know, it is having the longest wavelength in the visible spectrum, right? In the visible spectrum, we have got 7 colors, right? Red, orange, yellow, green, blue, indigo, violet. So out of these, red has the longest wavelength. So here the longest or the larger number is this one. So the correct answer for this question should be this one, is it? Now moving on to the next question. Here it is. So here, observe the given figure and answer the following questions. So here it is, we can see this diagram. This is the incident ray, this is the refracted ray. This CD is the normal here, okay. AN is the incident ray and this NB, this is the refracted ray. This is glass and this outside medium is air. So we can see that the light is traveling from air to glass. Now, the question is, name the process represented by the figure. So what process is it? So definitely this is refraction of light, isn't it? Because we can see here that the incident ray changes its path a little bit. It is deviated a little bit after passing through the glass, right? From air to glass, when it enters, then it bends a little bit. It changes its path a little bit. So this phenomenon is itself called as refraction of light. Next, state the 2 laws related to the process. So here, this is the refraction of light. This is the phenomenon, and we have to state over here the laws of refraction, right? So as we know, there are 2 laws of refraction, okay. One of them says that the incident ray, the refracted ray and the normal, all of these lie in the same plane, right? This is one of the laws. Then the second law is nothing but the Snell's law, okay. This is a form of a Snell's law which says that the relative refractive index, that means if the refractive index of this glass is, let's say, N2 and refractive index of air, that is medium 1, is N1, then the ratio of sin I upon sin R, right? So here what we have done is, we have taken the ratios of sine of angle of incidence to the sine of angle of refraction. So this ratio is numerically equal to N2 upon N1, where over here N2 is the refractive index of glass, N1 is the refractive index of air. Basically, refractive index of air is nearly equal to 1. So, technically, this can be written as equal to N2, which is the refractive index of the denser medium glass in this case. So, basically, these are the two laws of refraction that you have to state over here, right? So, this is going to be the answer for this question. Moving on to the next question. Here it is again. Now we are in the year 2021. So, here we have to again explain the laws of refraction. So, just now we have discussed the two laws of refraction, right? So, same is going to be the answer for this question also, right? So, this is done. Moving on to the next question. With the help of neat labeled diagram, prove that the rainbow is the combined effect of the refraction, dispersion and total internal reflection of light. So, here you will have to draw the diagram of that water droplet, isn't it? In which the ray of light from the sun enters and then over there it disperses and again it reflects and then forms a rainbow. So, that diagram you have to indicate over here. Okay. So, this is a 5 marks question. Okay. Moving on to the next. Here it is. Now we are into the year 2022. Okay. So, this is a MCQ for 1 mark. So, here we can see dash color is deviated the least in the spectrum of white light obtained with a glass prism. So, which color is deviated the least? Okay. So, here as we know, red color is the one which is deviated the least because it is having the longer wavelength. And if you talk about the refractive index, then the refractive index of materials like glass, okay, it is the least for red color. Okay. So, that's why this is least deviated. Okay. Moving on to the next question now, again from the year 2022. So, here it is. Here we have to match the column. Again, it's a very short answer question for 1 mark. Okay. So, definitely the refractive index of water is 1.33. Moving on to the next question. Again, we have got the same question. So, state the laws of refraction. So, just now we have discussed, right? Previously also we have had this question, right? So, this question seems to be very, very important for the upcoming exam also. So, you have to study this thoroughly, properly, so that you get full marks for this question. Okay. So, just now we have already talked about these two laws. Moving on to the next question. If the speed of light in a medium is 1.5 into 10 to the power 8 meter per second, what is the absolute refractive index of the medium? Here, the speed of light in vacuum is 3 into 10 to the power 8 meter per second. So, here we have to calculate the absolute refractive index, and it's very, very simple. The absolute refractive index is nothing but C upon V, where C is the speed of light in vacuum, whereas V is the speed of light in the given medium. So, we can put the numbers, right? The numbers are given. This is speed in vacuum, 3 into 10 to the power 8 meter per seconds. And here in the medium it is 1.5 into 10 to the power 8 meter per seconds. So, if we just divide this, then you get 2, right? 10 to the power 8, this meter per second, all of this will be gone, and this, when you divide, you get 2. So, the answer is 2, right? So, this is very, very simple question for 3 marks, right? So, this was a quite simple question, and you can see it's just a 2 or 3 steps answer and you are getting 3 marks. So, it's a very, very easy question. Okay. Moving on to the next question now. Now, we are into the year 2023. Okay. Now, the question is very simple. A ray of light passes from a denser medium to a rarer medium in a straight line. the angle of incidence must be what? So here 4 options are given. This is a MCQ for 1 mark, and the light is traveling from denser to rarer. Let us say that we have got water, or let's say a glass slab, and let us say that the ray of light is traveling straight. Is it? Somewhat like this. So in this case, definitely the angle of incidence has to be 0 degree according to the Snell's law. So according to Snell's law, if you go, then Snell's law states that N2 upon N1 is equal to sine I upon sine R, right? This is angle of incidence I, angle of refraction R. N2 is the refractive index of the second medium. Here glass is the medium 1, so N1 is the refractive index of medium 1. Okay. Now, if you just rearrange this equation, you are going to get N1 sine I is equal to N2 sine R. Okay, here it is I and that is R. So, over here, since it's a straight line travel, that means angle of incidence and angle of refraction both have to be 0, and this is only possible, is it? If I is 0, then only R can be 0. If I is not 0, then R can also not be 0. So that's why I over here, the angle of incidence must be 0, okay, according to the Snell's law. So in this way, the answer is very simple, that is 0 degree. Okay, moving on to the next question here. Again from the year 2023, it's a very short answer question for 1 mark. Match the columns. Here we have got 2 columns, column A, column B. We have been given a substance, that is air, and refractive index of air, as we know, is 1.0003. So it is nearly equal to 1. Okay, so this is the answer. Next over here, state true or false. Wavelength of red light is close to 700 nanometers. So this is definitely true, is it? So this is going to be the answer. Moving on. Here it is, another question from the year 2023. Observe the figure and name the ray AB, CD and ray GH. So here it is. This is the ray AB, this is the ray CD, and this is the ray GH, as we can see. So definitely AB is the incident ray, CD is the refracted ray, and GH is the emergent ray, right? So this is very simple question, okay, and it is for 3 marks, okay. So you can easily get the 3 marks over here, right? Let's move on. Now here, what we are going to do is some of the questions that we had discussed from different years. Now here we are going to look at the detailed solution for some of the questions. Okay, already we have discussed the solutions for all the questions previously. Okay, but here also we are going to see some of the solutions. Now, the observation made by Swarali while doing the experiment are given below. So we have already read this question, but let's have a look at this once more. Based on these right answer to the questions, Swarali found that the light ray traveling from the denser medium to rarer medium, okay, goes away from the normal. If the angle of incidence I is raised by Swarali, the angle of refraction R went on increasing. However, after certain value of angle of incidence, the light ray is seen to return back into the denser medium. Okay, so this is the observation that she has got, and these are the question. What is the specific value of I called, and what is the process of reflection of incident ray into denser medium called? Then draw the diagrams of 3 observations made by Swarali. Okay, so here it is. Let's look at the answer. First, the specific value of I is referred to as critical angle. So this is very important over here. Okay, when we talk about this phenomenon, when the light travels from a denser medium to a rarer medium, okay, in that case, there comes an angle at which the ray of light, okay, does not refract out. It just goes parallel to the interface between two mediums, and that angle of incidence at which this happens, this is called as critical angle. Okay, then next, total internal reflection. So this phenomenon is basically called as total internal reflection. That means when the light is traveling from a denser medium to a rarer medium, then if the angle of incidence is just a little bit above critical angle, or let's say nearly equal to critical angle, or let's say greater than critical angle, then in that case the light does not refract outside, it just reflects, okay, inside the medium itself, and this phenomenon is called as total internal reflection. And here it is. This is the diagram which shows this phenomenon and which shows the observations that Swarali has got. So here it is, as we can see, this is the incident ray. Now this is, let's say, the denser medium and this is the rarer medium. So light is traveling from denser medium. Initially the angle of incidence is small and we can see the ray of light is traveling out and it is going away from the normal. Then she has increased the angle of incidence, and here we can see at this angle the ray of light is traveling parallel to the interface between the two mediums. This line here, okay, the horizontal line, this is the interface between the two mediums, that is rarer medium and denser medium. Okay, so here we can see the refracted ray is actually parallel to the interface, and this angle of incidence I2 at which this happens, this is called as the critical angle. And if the angle of incidence is even further increased, okay, then the light will not be able to escape out, it will just be reflected inside, it will follow the laws of reflection. And therefore over here you can see light is reflected. Okay, so this is called as the total internal reflection. Okay, so let's talk about these rays. Okay, so observation 1 that Swarali has got, when I1 is less than IC, that is critical angle, this is the angle of incidence in the first observation and it is less than critical angle, then in that case refraction takes place and the refracted ray moves away from normal, that is R1 is greater than I1. Okay, then observation 2, when I is equal to critical angle, here you can see I1 is equal to IC, that means incidence angle is equal to critical angle, then in that case the refracted ray becomes perpendicular to the normal, or we can say parallel to the interface. So in that case R2, that means the angle of refraction is 90 degrees. Then the third observation is, when the angle of incidence is greater than critical angle, then total internal reflection takes place, that is here I3 is equal to R3. So here R3 basically represents the angle of reflection, not refraction. Okay, so where IC is the critical angle. So these are the observations that Swarali has got, and we have drawn the diagram also. Moving on to the next question now. Here the question is, if the speed of light in a medium is 1.5 into 10 to the power 8 meter per second, what is the absolute refractive index of the medium? Speed of light in vacuum is given, that is 3 into 10 to the power 8 meter per second. This is from the year 2022 for 3 marks. Already we have discussed this previously, but let's again discuss this. So absolute refractive index of medium is speed of light in air or vacuum basically divided by speed of light in the medium. So let's put the number, and after putting the numbers we get 2, right? This is speed of light in air and this is speed of light in the medium, and after we divide we get 2, right? So the absolute refractive index of the medium is 2. Okay, moving on to the next question. Observe the figure and name the ray AB, CD and GH. So we have already discussed this. AB is the incident ray, CD is the refracted ray and GH is the emergent ray, right? So this is the answer over here. Ray AB incident ray, CD is refracted ray and GH is emerged ray, right? So these are some of the previously asked questions from the last 5 years of the Maharashtra State Board from the chapter Refraction of Light. Okay, so today in this lecture we have discussed the last 5 years of questions and their solutions also, right, from the Maharashtra State Board examination for science subject. And today the chapter that we have discussed is Refraction of Light, right? So I hope everything that we have seen today is clear and very well understood. Thank you so much for watching and all the best for your examination. Thank you.